Good day, students. Today we want to solve problem that involve radius of the moon and mass of the earth. What you need to do is to write the relation. The question asks us to look for the value of the acceleration due to gravity on the moon's surface. We know that on the earth's surface, which is 9.8 meter per second squared. Now the relation between acceleration due to gravity and gravitational constant is as follows. GME equals to GRE squared. We got it from F equals GMEM over RE squared equals to weight and is equal to mass times acceleration due to gravity. You have to relate the weight of the object, which is the satellite, with the gravitational force of attraction that makes it to stay together, that makes them to stay together. For example, the astronomical body, which is the Earth, with the satellite as it's revolving around the Earth, and this is the Earth, the satellite as it's revolving around the Earth. There's gravitational force that is holding the mass of the object, which has its own weight, and this is the Earth also. The force, it has a relation in which we are going to relate the two together. From there, M cancel M, mass of the satellite mass cancel the mass of the satellite. Here we are left with GME over RE squared equals to G cross multiply GME equals to GRE squared. This relation is very important. We are going to make use of it. That's how we got the relation here. Is that okay? Now we can now get some equation from there. Since we are looking for the acceleration due to gravity on the moon's surface, and we know that of the Earth, we are going to get some relation. You divide both sides by RE squared, so that you'll be left with expression for acceleration due to gravity, which is GME over RE squared. Is that okay? Now you can now say G of the Earth, acceleration due to gravity on the Earth, is GME, which is this expression, over RE squared, equation 1. And also we can still write it as GM equals GM subscript M over RM squared. This is for the moon. Okay, since universal constant, since G, like that, since capital G is the universal constant of gravitation, it is constant for both equations. Is that clear? Now what we need to do is to read the question very well. Radius of the moon, just write RM. This is our equation 2. RM is 1/4, 1/4 of its mass. 1/4, and its mass is 1/8 that of the Earth. Okay, 1/4 of the mass of the Earth. You see, radius of the moon is 1/4 of the radius. Okay, the two questions that are being asked. Radius of the moon is 1/4 and its mass is 1/8 that of the Earth. That this one will be Radius of the moon is 1/4 of radius of the earth. That's equation 3. Let's go to another one, and its mass. Mass of the earth equals 1/8 that of the earth. 1/81st. 1/81st that of the earth. That's okay. Mass of the moon. Mass of the moon is 1/81st that of the earth. Mass of the earth. You have to look at it very well. Question 4. Now you can still write this one very well. Rm equals 1 times Re over 4. Okay. Now this one, so you are still repeating equation 3. That's this one will be mm equals 1 times me over 81. I still repeating equation 4. Now from here, don't forget that we are dealing with, we have to make this one the subject of the formula. This is what we are looking for, value on the moon. We have to get the expression for acceleration due to gravity in this first equation. This is what we are looking for. We are concerned with this, but this one is already given to us from the expression, initial expression from here. Because this acceleration due to gravity due to the earth, but this is what we are looking for. You now deal with this one by making G the subject of the formula and substitute in the moon. Okay, you now say from equation 1, make capital G the subject of the formula and substitute it in equation 2. Okay, because we are concerned with mass acceleration due to gravity on the moon. We now go back to equation 1, which is this. Now GME equal to GERE squared. Make G the subject of the formula, divided by ME divided by ME. ME cancel ME. G now equals GERE squared over ME. You now substitute in equation 2, because this is what we are after. What is the value of the acceleration due to gravity on the moon surface? That's why we are concerned with this. Do your substitution here and substitute it. Make your G the subject of the formula here and substitute it in GM. Now from equation 2, now your GM equals G, substitute it now, GERE squared over ME. Okay, multiply by, separate this, M as on the moon over radius of the moon squared. Okay, see this one is RR, collect the like terms, GM equals GE multiply by RE over RM squared multiplied by MM over ME. Is that okay? Now since we have something like this, do you have R? We now try to make this one subject formula from equation 2 now, from equation 3, from equation 3, let's get expression like this. We have Rm equals Re over 4 by 1. Let's cross multiply. 4Rm equals Re. Now we need Re over Rm. Divide both sides by Rm so that this will cancel out. You now have Re over Rm to be equals to 4. We have gotten that. You do a substitution here. Let's go to the second equation. From equation 4, you have m equals me over 81. What expression do you have? Over, let's cross multiply first. That's, we have 81 equals me. We need over me. Divide both sides by me. Divide by me. Divide by me. This will cancel this. You have 81 over me equals to 1. Divide both sides by 81. Divide by 81. This cancel this. You have over me equals 1 over 81. Okay, now we can now substitute into that. You now go back and say that gm equals to ge dot re over rm squared multiplied by m over me. Now do that. You have ge, you have it gravity action due to gravity on the surface of the earth, which is 9.8, which is 9.8 times re over rm, which is 4 squared multiplied by 1 over 81. 1 over 81. Now gm equals 9.8 times 16 times 1 over 81. This over 1 over 1. When you multiply the numerator, you have 156.8 divided by 81. When you press your calculator, gm equals 1.94 meter per second squared. Okay, that's the value of acceleration due to gravity on the moon's surface. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.